What if I told you an 8-pin chip and a handful of parts can tell you whether a transistor is alive or dead in seconds? No data sheets, no guesswork, just flip the switch, plug it in, and let the 555 timer expose the truth. Hey guys, in this video I'll show you how to make a transistor tester circuit with a 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 3 alligator clips, 9 jumper wires, 1 kilo ohm resistor, 1 2.2 kilo ohm resistor, 1 100 ohm resistor, 1 10 kilo ohm resistor, 1 100 microfarad capacitor, 1 green LED, a 9-volt battery buckle connector, a 9-volt battery, 1 555 timer IC, 1 10 kilo ohm potentiometer, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a 100 microfarad capacitor into pin 2 or trigger in the negative rail. The anode is in pin 2. Bend the ends of a 1 kilo ohm resistor. Insert a 1 kilo ohm resistor into pin 7 or discharge and the positive rail. Bend the ends of a 100 ohm resistor. Insert a 100 ohm resistor into pin 7 or discharge in a few rows below the 555. Insert a jumper wire into pin 6 or threshold and 2 rows below the resistor. Insert a jumper wire into pin 6 or threshold and 2 rows below the previous jumper wire. Insert a 10 kilo ohm potentiometer into the same rows as the resistor and the jumper wires. Bend the ends of a 2.2 kilo ohm resistor. Insert a 2.2 kilo ohm resistor into pin 3 or output in a few rows below the 555. Insert a jumper wire into the same row as the resistor. Attach an alligator clip to the other end of the jumper wire. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor into the middle of the breadboard and the positive rail. Insert a green LED in the same row as the resistor and a few rows below it. The anode is in the same row as the resistor. Insert a jumper wire into the same row as the LED. Attach an alligator clip to the other end of the jumper wire. Insert a jumper wire into the negative rail. Attach an alligator clip to the other end of the jumper wire. It's time to connect the power supply. Connect the 9-volt battery buckle connector to the 9-volt battery. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. Now let's put this BC547 to the test and see if it's still alive. Since it's an NPN transistor, the pins are arranged as collector, base, and emitter in that order. Attach the red alligator clip to the collector. Attach the green alligator clip to the base. Attach the black alligator clip to the emitter. The green LED keeps blinking steadily. As I turn the knob on the potentiometer, the blinking speeds up. That change tells us the transistor is alive and responding exactly as it should. Let's run the same test on a BC557. Since this one is an PNP transistor, the pins are laid out as emitter first, then base, and finally the collector. Similar to the previous transistor, the LED flashes in a clean, steady rhythm. As I turn the potentiometer, that rhythm speeds up and the blinking becomes faster and faster. How do you know if your transistor is dead? Good question. Here's a BC547 that is dead. How do I know? The LED does not light up when this transistor is connected to the circuit. As you can see, even when I turn the potentiometer, the LED stays completely off, no response at all. Let's dive into the circuit and break it down step by step. This circuit is a simple but clever transistor tester built around a 555 timer, and its job is to tell you whether a transistor is working and whether it behaves correctly as an NPN or PNP device. At the heart of the circuit, the 555 timer is wired as an astable oscillator, meaning it continuously generates a square wave signal at its output, or pin 3. This oscillation is created by R1, R2, VR1, and C1, which form the timing network. The capacitor C1 repeatedly charges and discharges between roughly 1/3 and 2/3 of the supply voltage. When C1 charges through R1, R2, and part of VR1, the voltage at pin 2 and pin 6 rises. When it reaches the upper threshold, the 555 flips state and pin 7, or discharge, pulls the capacitor down through R2 and VR1. This repeating charge-discharge cycle produces a pulsing output at pin 3. The potentiometer VR1 lets you adjust the speed of this pulsing, which can make the test indicator easier to see. The output, or pin 3, is fed through R3 to point B, which is always connected to the base of the transistor under test. R3 limits base current, so the transistor is not damaged, and ensures safe operation for small signal devices. Because the 555 output swings between near 0 volts and near 9 volts, the base of the transistor is repeatedly driven high and low. This is the key idea of the tester. The transistor is constantly being switched on and off. The circuit is designed so that the same socket works for both NPN and PNP transistors, but the pin interpretation changes. For an NPN transistor, A is the collector, B is the base, and C is the emitter. For a PNP transistor, A is the emitter, B is the base, and C is the collector. This labeling allows the circuit polarity to remain fixed while the transistor type changes. R4 and the LED are connected in series to point A in the positive supply. This LED is the visual indicator. It lights only when current flows through the transistor between A and C. The transistor itself acts as a switch controlling the LED. When the transistor is off, no current flows and the LED stays dark. When the transistor turns on, current flows through R4, the LED, and the transistor, causing the LED to light. Here is how it behaves with an NPN transistor. When the 555 output goes high, base current flows through R3 into the transistor's base. This forward biases the base emitter junction, allowing current to flow from collector, A, to emitter, C. As a result, the LED turns on. When the 555 output goes low, base current stops, the transistor turns off, and the LED turns off. If the transistor is healthy, the LED will blink on and off in sync with the 555's oscillation. If the LED never lights, the transistor may be dead, incorrectly inserted, or have an open junction. If it stays on constantly, the transistor may be shorted. For a PNP transistor, the behavior is mirrored but still works because of how the transistor is connected. When the 555 output goes low, the base becomes more negative relative to the emitter, forward biasing the base emitter junction of the PNP transistor. Current now flows from emitter A to collector C, again lighting the LED. When the 555 output goes high, the transistor turns off and the LED goes dark. The blinking LED still indicates a healthy transistor, just with opposite base drive polarity. I hope this video has shown you how to make a transistor tester circuit with a 555 timer. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.